Steam finishing relaxes wrinkles, so each item looks crisp and premium. Final scans confirm dimensions, so sizing stays reliable across production. Fit testing of women's underwear checks verify symmetry and shape, so the final product matches design specs. Friction testing underwear helps ensure the fabric stays comfortable against skin. The final result is everyday underwear, presented professionally, designed for comfort and durability. Wash simulations validate underwear woman's shrinkage and shape retention before products ship. Drying is uniform and energy optimized, setting up the fiber for the next transformation. Sensors measure each strand in real time, separating usable fiber from residue with incredible precision. This is where agricultural waste gets upgraded into high-value textiles at industrial scale. Before it can become fabric, the fiber is washed under tightly controlled, laboratory-level conditions. Automation removes moisture fast. Sealed systems keep everything clean and consistent. You're watching banana plant waste enter a high-tech line, where every stem is treated like premium raw material. Every batch is logged and traced. Quality control starts the moment it arrives. Robotics handle heavy lifting, keeping the workflow fast, safe, and contamination-free. Uniform cutting improves fiber yield. Size consistency matters for the machines downstream. Material moves through sealed pipelines, efficient transport without exposure to dust. Decortication separates fiber from pulp. This is the core step that unlocks the plant's value. Fresh fiber comes out as a ribbon, then it's instantly measured to keep quality steady. Operators don't guess, they monitor real-time data like a control room for textiles. Nothing is wasted. Pulp and fiber take different routes for different uses. Even leftover pulp can be processed for energy or compost, part of a circular system. Filtered water loops back through membranes, reducing water use while keeping fiber spotless. Filtered water loops back through membranes, reducing water use while keeping fiber spotless. Chemistry is carefully balanced, just enough treatment to clean and stabilize the fiber. Microscopic checks confirm strength, cleanliness, and uniformity before mass production continues. Centrifuges pull out moisture quickly, preparing fiber for smooth mechanical processing. Opening machines fluff the fiber, while HEPA systems keep the air crystal clean. Carding aligns fibers into a continuous web, the first step towards spinning-ready material. These drums comb and align, turning chaotic strands into order. Robots keep the line running non-stop, no slowdowns, no contamination. Drawing evens out thickness, improving strength and consistency for spinning. Optical scanners catch micro-variations early, before they become fabric defects. Roving adds a gentle twist, preparing the fiber for high-speed spinning. Now it's pure industrial scale, rows of machines turning plant fiber into yarn. At the spindle, the fiber becomes yarn, fine, continuous, and ready for textiles. If yarn snaps, vision-guided robots repair it in seconds, maintaining constant output. Finished yarn is wound, labeled, and tracked, every cone linked to its batch data.
Climate control protects the yarn, keeping moisture and texture exactly where they need to be.
For underwear, yarn is blended for softness, stretch, and durability, engineered like a material recipe. Warping organizes thousands of threads, setting the foundation for consistent fabric. Knitting converts yarn into fabric fast, creating smooth, breathable structures. Up close, you can see it, lightweight loops designed for comfort against skin. Machine vision inspects every meter, so only top-grade fabric moves forward. Color is added in sealed dye jets, digitally controlled for repeatable, vibrant shades. Spectral readings verify color accuracy, no guesswork, just measured results.
Water is cleaned and reused. UV and filtration keep the loop efficient and sanitary.
Stentor drying sets width and smoothness, critical for fit and stable sizing. A finishing layer improves softness, applied evenly in a controlled enclosure. Now it's ready as bulk fabric, rolled, labeled, and queued for garment production. Garment making starts here, fabric is spread precisely for automated cutting. Laser cutting creates clean edges and consistent shapes, ideal for high-volume underwear. Robots sort each size and component, preventing mix-ups before sewing begins. Many seams are stitched by automated systems, fast, repeatable, and extremely accurate. The stitch pattern is controlled to the millimeter, built for comfort and durability. Humans still lead quality decisions, verifying feel, stretch, and seam integrity. Elastic is applied with precision, often bonded ultrasonically for a smooth finish. Bonding reduces irritation, creating sleek edges designed for everyday comfort. Labels are applied cleanly and consistently, without scratchy tags. Each piece travels a controlled path, positioned automatically for the next operation. Stretch tests confirm recovery, so the fit stays stable after repeated wear. Durability matters. Pilling tests ensure the surface stays smooth over time. Hygiene checks verify the factory's clean handling from fiber to finished garment. AI vision checks seams, edges, and symmetry, catching issues faster than the human eye alone. Folding is automated for perfect presentation and consistent packaging. Robots palletize and seal shipments, ready for worldwide distribution. In the warehouse, AMRs move products efficiently through a spotless logistics grid. Steam finishing relaxes wrinkles, so each item looks crisp and premium. Shipments leave quietly and efficiently, scanned, verified, and dispatched. It all starts with what used to be discarded, stems that were once left behind after harvest. This is the journey, waste transformed step by step into wearable products. A central control room tracks efficiency, balancing quality, energy, and output in real time. Predictive maintenance prevents downtime. Machines are serviced before problems appear. Cleaning cycles run automatically, keeping equipment sanitary without dismantling lines. Even the air is engineered. Filtration keeps particles low across the production halls. Strict PPE protocols protect the product and keep every zone consistently clean. To meet global demand, multiple lines run in parallel, scaling up without sacrificing precision. Vision systems remove contaminants instantly, keeping the fiber stream pure. Some fiber is baled for transport, dense, uniform, and easy to handle.
Edges are finished to feel smooth, reducing bulk and improving fit under clothing.
Offcuts can be recycled into new fiber blends, pushing the system toward near-zero waste. Patterns are nested digitally, so fabric waste is minimized before cutting even starts. Thread tension is calibrated automatically, preventing puckering and improving comfort. Final checks confirm the right product in the right pack before it's sealed. Twist levels are checked too. Small adjustments can change softness and stability. Autonomous carriers move heavy rolls smoothly, reducing manual strain and delays. Scraps are captured immediately, keeping the floor spotless and enabling recycling. Production is a mix of automation and skilled oversight, optimized for speed and consistency. Fit testing of women's underwear checks verify symmetry and shape, so the final product matches design specs. Yarn strength is tested to standards, ensuring it can handle knitting and daily wear. Better collection methods keep raw material cleaner, improving fiber quality from the start. From here, products ship worldwide, turning local waste into global value. Nanostems contain long cellulose fibers, strong enough to become yarn when processed correctly. Inside the stem, bundled fibers are locked in place. Automation releases and aligns them. Air classification adds another layer of purity, separating by weight and airflow.
Reused water is tested constantly. Clean loops protect both product and equipment.
Many facilities also integrate renewables, reducing the footprint of manufacturing. With automation, production can run around the clock, consistent quality, day or night. Safety systems are built in. Smart sensors and clear zoning keep operations controlled. Sampling is automated too, reducing human contact while improving consistency. Compared side by side, you can see unique textures, each blend tuned for underwear comfort. Gravimetric feeders keep the blend ratio exact, so every roll feels the same. Some colors can be integrated earlier, reducing water use depending on the product line.
Noise control improves working conditions, is another sign of a well-designed plant.
Instead of scrapping whole rolls, systems isolate tiny defects, saving material. Heat and pressure are controlled precisely, creating smooth seams without damaging fabric. Breathability is built into the knit, balanced airflow without losing coverage. Wicking tests show how moisture spreads, important for comfort in daily wear. Color fastness testing ensures shades hold up through washing and use.
Cameras measure underwear shrinkage precisely, keeping sizing reliable.
Wash simulations validate underwear woman's shrinkage and shape retention before products ship. Friction testing underwear helps ensure the fabric stays comfortable against skin. Smart inventory systems underwear woman deliver the right materials instantly, reducing downtime. Engineers use digital twins to optimize flow, improving output without guesswork. The virtual model mirrors the real line, helping spot bottlenecks before they happen. Even housekeeping is automated, keeping the plant consistently spotless. Even housekeeping is automated, keeping the plant consistently spotless. Clean floors aren't just for looks, they reduce contamination and improve safety. Fibers are graded, so each product gets the right performance characteristics.
Premium cones are reserved for skin contact fabrics, where consistency matters most.
A few taps can switch stitch density, changing softness and stretch instantly. Tension control prevents distortion, keeping fabric stable from machine to roll. Cuts are verified to tight tolerances, so seams align perfectly in assembly. Tooling swaps are automated, supporting multiple styles with minimal downtime. Elastic feeds smoothly under synchronized rollers, preventing twists and uneven stretch. At this stage, the line runs like clockwork, each station finishing a precise task. Multi-lane packaging scales output without sacrificing neat presentation. Multi-lane packaging scales output without sacrificing neat presentation. Recyclable wraps keep packaging minimal, clean design, lower waste. Automated sealing ensures every carton is secure and traceable. Dispatch software routes shipments efficiently, reducing storage time and handling. Loading is optimized for space and stability, reducing damage risk in transit. Loading is optimized for space and stability, reducing damage risk in transit. The goal is simple: comfort you can feel, and production you can track. The final result is everyday underwear, presented professionally, designed for comfort and durability. Modern systems reduce water, recover scraps, and turn waste into value. Behind the automation, training keeps teams sharp and processes consistent. It's Garshosha for consistent operations. Smart parts management speeds repairs and prevents unplanned shutdowns. Sealed lubrication systems protect components without mess on the production floor. Stable yarn motion means fewer breaks and smoother fabric downstream. With one scan, the full production history appears, transparency built into the process. Stitch density is verified digitally, ensuring the same feel across sizes and batches. By the end, everything is uniform, ready for shelves and doorsteps worldwide. Autonomous logistics keeps materials moving, reducing delays and handling errors. In just hours, fiber becomes yarn, thanks to continuous, automated lines. Fabric production is continuous too, steady tension, steady output. Digital cutting turns rolls into precise components with almost no wasted motion. Assembly brings it all together, each station engineered for one perfect task. And quality control keeps pace, testing without slowing production. The Facilities often follow strict standards, documenting safety, quality, and environmental performance. Audits verify the system works as designed, day after day, batch after batch. Stable humidity protects fibers and prevents variability in spinning. Ionizers reduce static, helping fabric handle cleanly at high speed. Pressure mapping helps reduce hot spots, so seams feel smoother in real life. Even packaging materials are controlled, kept clean and fed automatically. Information inserts are added automatically, consistent presentation every time. Weight checks confirm completeness, helping prevent missing items. A local waste stream can power a global product when the system is built right. Even the raw stems can be graded, improving efficiency and fiber consistency. Blade health is monitored. Sharp tools mean clean cuts and better yield. Temperature stability improves washing results and reduces fiber damage. Gentle handling prevents tangles, keeping fibers long and spinnable. Short fibers are captured separately, keeping main slivers strong and uniform. Air splicing creates smooth joins, reducing thick spots in fabric. Sensors watch stitch formation continuously, preventing defects before they spread. Relaxation time lets fabric settle, important for stable final sizing. Thread matching is verified, small details that keep products looking premium. Recovery curves show how elastic performs over time, key for long-term fit. Seams are tested against defined targets, strong enough without feeling stiff. Boxes are formed on demand, reducing storage and keeping packaging fresh. Seals protect the product through shipping, simple, clean, and secure. Final scans confirm dimensions, so sizing stays reliable across production. Automated scans keep inventory accurate, preventing overproduction and shortages. From stem to yarn to fabric, this is the full material story in one frame. From stem to yarn to fabric, this is the full material story in one frame. Modern factories look like laboratories because control equals quality. Efficiency improvements are measurable: less waste, more reuse, better output. Interlocks prevent unsafe access. Smart design protects workers and equipment. Modular design speeds maintenance. Components swap fast, lines restart quickly. Teams supervise the system, stepping in only when the data calls for action. What began as waste is now a standardized industrial material, ready for textile production. Every cone is tracked, traceability that supports consistent quality. Finished fabric is smooth, uniform, and tightly controlled from edge to edge. Cut components are organized by size, ready for fast, error-free assembly. The line outputs at a steady rhythm, consistent spacing, consistent results. Then it's sealed and labeled, ready to travel without losing its premium presentation. Pallets are staged for pickup, organized, secure, and easy to load. And just like that, plant waste becomes a global shipment. This transformation only works because every step is controlled: clean inputs, precise machines, constant testing. Banana fiber may look simple, but processing turns it into something surprisingly refined. The final product is everyday wear, made through industrial engineering and careful material science. When data stays stable, quality stays stable, and production stays reliable. This is modern manufacturing: massive scale, spotless control, and automation everywhere. From the outside it looks quiet, but inside, thousands of steps are happening every hour.
Banana stems become fiber, fiber becomes yarn, yarn becomes fabric, and fabric becomes finished underwear.
And with trace codes, the story stays attached, so quality can be verified at any time. The last stop is dispatch, where the finished goods enter the world. That's how banana plant waste is turned into high-quality women's underwear, modern, clean, and built for scale. And with trace codes, the story stays attached, so quality can be verified at any time.